Started. Hello everyone, I'm Tomek Mrugowski and Wiki introduced me already, so let's cover the topics that we'll be talking. So I'll try to give some hints about optimizing DHCP performance. So I'll start with the very obvious stuff, go through multi-threading, different aspects of list storage, host reservation, client classification, hardware platforms, the importance of minimizing latency, different tips for high availability, how to reduce iterations, what hooks to avoid and what's their impact on latency, and a bunch of things that you should avoid, and some final notes about fine-tuning. So let's start with the pretty obvious things. This is the table produced by Cisco, but it's pretty basic math. You can come up with your own numbers for your network. Keep in mind that for your specific deployment, usually your number of active leases is more or less constant. Depends on how many devices are there in your network. But you can play a lot of tricks with tweaking the lease times. So, for example, in cable networks, it's pretty common to use very long lifetimes, like 1 week. And then if you even have 1 million modems, it comes up as on average to only 4 leases per second. However, those are never distributed evenly. So this is something to remember. So in some cases, people say, oh, but I don't need that much performance. Usually you don't. But in some cases, when there is a blackout in your whole neighborhood, and suddenly there are thousands of devices coming up online, all of them want to get an address. So, and in those cases, you need this extra performance. So there's a lot of aspects that affect the performance. So how many clients? This is the pretty obvious one. Whether clients renewing or getting a new address, whether you're hammering the server with a lot of API requests, whether you have bad clients that attempt to renew too early, what are your lease expiration times, renewals, HA, and many other things. So the first obvious thing you should do is to upgrade. This is not the usual mantra that, hey, you need to upgrade to the latest version. There are really good technical reasons why migrating to new version makes sense from the performance perspective. So if you are on very old versions like 1.4 or even older, please upgrade instantly. 1.6, which is EOL now, it was single-threaded. With 1.8, we added multi-threading for packet processing. So if you run a single server, you could benefit from multi-threading. However, if you run it in HA configuration, which is a very popular choice for obvious reasons, then the bottleneck was the HA communication. So we addressed this in 2.0. That's the reason. That's one of the reasons why we decided that it shouldn't be 1.10. It's really 2.0, because this is like a really fundamental change in how Kia is operating. And we continue the development in 2.1 series. So we added cache threshold, subnet selection speed up, early global host reservation lookup, and we're working on a couple other things. So, and those features will be released in stable 2.2 that's expected in a couple months. Also, compared to ICDHCP, Kia is very modular. So there are many things that are that the code is available in hooks, and one of the reasons is that this modular approach makes them optional. So you don't need to load them. But this also applies to some features of the base code, like if you don't need host reservations, don't use it. The same with HA and shared networks and logging and basically any hooks. So throughout this presentation, I'll be talking about various test results. So this is the test setup that we're using. So we have two pretty powerful, but I would say, like a middle range. So they're not top of the line. They are pretty decent servers. So they have Intel Xeon 3.5 gigahertz with a 6 core with multi-threading, so that we can run 12 threads, 64 gigs of RAM. There's triple SSD disks in each of them, although this is not really necessary. We came up with this configuration because we wanted to do a comparison between a single disk and various write configurations, but we haven't got there yet. So we have two 10 gig interfaces, and we're running on pretty old OS. That's Ubuntu 18.04. If you're interested in the details, the links are on the slide. The slides will be made available. So one small caveat, all the test results for MySQL, there's a tweak that we're doing. This is a configuration knob called TRX commit. It makes MySQL to write a journal file to disk, to sync the journal file to disk every 1 second, not after every update. So this has substantial impact on performance. Okay, so the first thing is multi-threading. Obviously, you want to enable multi-threading. So in DHCP v4 and in DHCP v6, it's exactly the same. There's a section called multi-threading, and within it, there's a flag enable multi-threading. You set this to true, but this is not the only parameter that you can tweak. And the other parameters are thread pool size. So basically, how many threads you want Kia to create to deal with the packet processing. And here it becomes a little bit tricky, because this is not always more is better. So keep in mind that this is being run on a CPU that has 12 logical threads. So and here, as you can see, for different backends, there is a sweet spot, but it's not generic. Depending on what exactly are you trying to do. For example, if you are using memfile as backend, the best performance is with 8 threads. For v6, it's 4 or 6. And for different backends, the values are different. But please don't take this as granted. This is those results are very specific to the hardware that you have. If you have a different hardware for your deployment, this might be different. So the best recommendation is to do your experiments and play with the value and see what the numbers you are able to get. Okay, so another parameter that can be tweaked is packet queue size. So keep in mind that this is something that is shared by all the threads. So well, not shared, it's distributed to all threads. So if you configure, in this example, 8 threads, and you have packet queue size 80, that means that each thread will be able to buffer up to 10 packets. And here again, this is not possible to specify like one value that works everywhere. Although here it's a bit simpler in the sense that the larger value is usually safer, although it's not completely free. If you have larger buffer and the queue is larger, then the overall performance is higher. However, it takes longer to respond to a packet because the packets are FIFO, first in, first out. So that means that if, let's say, you configured a queue of 1,000 packets, so then the time the packet spent there, it's would be like very long, and this has some negative implications, like in particular, the client could get impatient and start retransmitting, which can cause an avalanche of retransmissions. So anyway, this is also a parameter that's a balancing act, basically. Okay. So we have a website, reports, kiic.org, where we publish performance results for various versions. And the latest version as of today is 2.02, and we expect to publish new performance results in the coming weeks for the development version. So anyway, here is a comparison between the general performance that you can get in various cases. So as you can see, enabling multi-threading across the board increases the performance. Although it was not just a simple flipping the switch and that's it. So for every backend, we chose the number of threads that is the most performance. So as you can see, in many cases, the performance improvements can be substantial. So in the most extreme cases, for memfile, we were able to increase the performance from 11,000 leases per second. By the way, the numbers specify leases per second. So to get a lease, the client went through the full DORA exchange. So 4 messages were exchanged. So this is leases per second. If you want to convert this to packets per second, you need to multiply this by 4. So for memfile, we increased the performance from 11,000 to close to 36,000. So this is the highest performance we were able to get. When we're talking about databases, of course, the performance is lower, but still with multi-threading, the database are particularly well suited for multi-threading access, and it's clearly shown here. Like for example, in hot standby for MySQL, when you enable multi-threading and play with the number of threads a bit, you can increase the performance from 500 to 7,000. So this is like 15, 16 times. So it's like a huge improvement. I mean, if you express this in percents, this is like 1,400, 1,500 percent. So this is substantial gain. So it's something that's really worth playing with. Although I must admit that this configuration is the simplest possible. The test was set up in a way that there is one huge pool, one huge subnet with one huge pool. So and all the clients were in this single pool. So this is like slightly simplified. Also, there was logging was tuned down significantly, and there was no additional processing. So, but still, this is a good benchmark to compare different backends. And by the way, this is something that you should consider. So, if getting absolutely the highest performance is your goal, and you don't care about any other aspects, absolutely go with memfile. This is by far the fastest. Memfile is a backend that we developed ourselves. So this is, as the name says, the data is stored in memory, and it's also written to local file. So since the data is optimized for reading from memory, it's substantially faster than any SQL solution. So the trade-off is that it's in memory, so you cannot use external tools to look at the database or tweak it easily during the runtime. Although there's API that you can use to do certain things like get statistics, update the leases, and so on. But still, it's not as flexible as using SQL solutions. Okay. So moving on, I also wanted to encourage you again to visit the website when we have interactive reports. So this doesn't show too well on the static slide. but for each of those bars that you can see, there's a different scenario with a lot of combinations, like additional client classes, multiple subnets, many reservations, 30% of the addresses reserved, and so on. So as you can see, it's not uniform. Depending on how complex is the configuration, some backends are more or less performant, and sometimes the impact of those parameters is substantial. So there is way too many scenarios to go through them. So on this webinar, so I encourage you to go to this report and see it for yourself. So the report is pretty big, so please be patient. It takes a bit to load, but once it's loaded, there's a lot of data there. But overall, for the list storage, the general guiding principle is that memfile is faster than MySQL, which is faster than Postgres. So also this might be a good point, a good time to point out that we are software engineers. We are not database admins and database experts. So it's possible that you might tweak the Postgres deployment to be more performant than MySQL, possibly. But this is outside of our area of expertise, so we'll not pretend that that we know exactly how to tweak a database. Okay. So moving forward, an important aspect of many DHCP deployments are host reservations. So this is the mechanism that allows you to reserve options which are not that important in the context of performance, but primarily reserve an address. So here's a generic case of 3 scenarios. First one is that you can tell Kia that host reservations are disabled. So basically you promise that, hey, there are no reservations, please do everything purely dynamic. So if you take a look at the top image, you have a subnet, and out of the subnet you have some addresses allocated as dynamic pool that Kia should allocate. So in most cases, this will be like almost the full subnet, except maybe the first or last address for broadcast and one for gateway. But it might be different depending on how your network is organized. But anyway, if you tell Kia that, hey, there are no host reservations in your network at all, or in this subnet, you get some performance boost because Kia will not bother with doing the reservation lookups. So that's the fastest approach. The second best is when you have to do reservations, do them out of pool. So reserve some address space, and this is like logical reservation. Say, okay, I need those last 20 addresses for my reservation, and my dynamic pool is different. So if you specify to Kia that the reservations are out of pool, then Kia knows when doing the dynamic allocation, there will not be any reservations in the dynamic pool. So it can skip all the checks. And that way, it still will get a reserved address for your device. But when doing the dynamic allocation, the second lookup will be skipped. And finally, the last, which is the safest and the default, and sadly the worst performing approach, is that Kia will not make any assumptions. Kia will assume that you can reserve anything anywhere. This gives people a good experience out of the box because you can just throw a reservation there and it will work. And in many deployments, people don't care about performance that much, but they would be very angry if Kia started assigning addresses that were reserved for someone else. So Kia assumes that this is the default. So And from the performance perspective, this is the worst case. So if you can, don't reserve addresses in your dynamic pool. Okay. So moving on, host reservations, they can also be defined on several layers. Up until, I think, 1.8, it was only possible to have subnet reservations. So for subnet reservation, the idea is what you would expect from a reservation. You have a device X connected to this subnet, and this reservation should get an address and maybe an option. So, and by the way, the reservation doesn't have to cover address. You might want to reserve only addresses, or even don't reserve anything. And the fact that there is a reservation for your device, this is useful in Kia in some cases. So, but I'm talking here about the typical case when the host reservation has an address. So this is useful when you have a well-defined structure in your network and you know where exactly the devices are connected and you want to reserve something. So a good example is a fixed network like cable modems, for example, or an enterprise where there are fixed desktop computers, VoIP phones that are fixed and they are not moving around. So for global reservations, the idea behind them is slightly different. So this is where you have a network with mobile devices, typically laptops or phones or whatever, and you don't really know where it will connect. So if you use the basic approach, you can do the host reservation in each subnet that you think the device will visit. But if you have extensive, complicated network, you might end up with lots of reservations. So that's not really useful. Although there's one important caveat here. Typically, you don't use address reservations for global. And because if you do, then the Kia will assign the address regardless of where the device is connected. And in most network topologies, this would end up in wrong configuration. But anyway, getting back to the topic of host reservations in the context of performance, it's possible to enable and disable those lookups. So the point here is that think first if you even want to use host reservations. If not, great, just disable them completely. Second, you might want to enable only those lookups that you really need. So in most cases, this would be subnet, but maybe if you decide that, hey, you want to have a global reservation in your network, do that and then disable lookups on the subnet level. And if you really cannot make up your mind, you can enable everything, but then you will pay the price in decreased performance. So with reservations, there's another thing. So Kia can do reservations by different things. By MAC address, by DUID, circuit ID, client ID, flex ID, and depending on what you configure, this type of reservation will be looked at. So again, the default is the Kia will look at all four of those reservations. So if packet comes in, Kia will do 4 lookups. First, is there any reservations for this MAC address? If not, check if there's a reservation for this DUID, and so on. And this is repeated 4 times for 4 different types. The reason is the same as before. It's safest out of the box, so people can put any reservation in their database or in the config, and it will work. But it's not the most performant. So in most managed networks, it makes sense to use one type of reservation. By far, the most common is reservation by MAC address, but it doesn't have to be. You might want to reserve by different properties, or even use flex ID to to specify your own unique way of identifying clients. But in any case, defining just one type of host reservation identifiers will give you a pretty nice performance boost from the host reservation perspective. Okay, so moving on, another potential speed bump, a pretty big one, is classification and expressions in general. This is a pretty nice way to classify and specify custom things when it's used in moderation. It can be used for a couple of things. Historically, the first one was client classification. Then we added the ability to use this in custom options and in custom logging, in forensic logging. And recently, there's a DDNS tuning hook that is being released today that will allow you to specify a host name based on an expression. So the tricky part here is that each packet is evaluated against each class and every expression that is specified. So that means that if you have many classes, even if the packet doesn't belong to this to any class, there is still performance overhead. What is even worse is that when the expression is split into tokens, and I will be talking about tokens in a minute, each token needs to be evaluated. So let's take a look at a good example here. So you might define a class that the name of the class is drop, which is a special reserved name which tells Kia to drop those packets that match this expression. And this expression has packet for message type equals 5. So speaking in terms of tokens, token is a primitive, it's the most primitive part of an expression. So in here, there are 3 tokens. Packet message type, this is 1 token, equals, this is second token, and 5, a constant value, it's a tiered token. So there are 3 tokens. And for every incoming packet in your network, those tokens will be evaluated. And for every packet, the final expression will be either false or true. And depending on this, the packet will belong to the class or not. So far, so good, because the expression is simple. But we saw some people doing very bad things, like the expression was very, very long. And the expression I saw had 70,000 MAC addresses here. So that means that for every packet incoming, there was over 210,000 tokens that have to be evaluated for every single packet, every time. And even if the incoming packet matched, the evaluation continued. So this was like extremely poor performance, and the users were complaining that they were getting around like 10 leases per second or something like that. So it was horrible. So please don't do this. Overall, if you think that you need a long expression in classification, you might want to consider what exactly you're doing. So probably you want to use host reservations for that. In host reservations, there's an ability to specify that certain clients belong to a class. This is way, way more performant. And this evaluation, it affects classification, custom logging, flex ID, and the host name in the upcoming DDNS tuning hook. Okay, so one of the many things that are available on the reports that I mentioned on our website is the test. What's the impact of classes on performance? So I picked 3 scenarios. So the first one is simply memfile with DHCPv6. I chose DHCPv6 because the absolute values are a bit higher than before. So the mechanism that I want to showcase here is more obvious. So the second scenario is the same configuration, except there's 100 empty classes defined. So there is no expression, so there is nothing to evaluate. But still, Kia has to go during each packet processing through a list of 100 classes, and every time there is a question whether something applies with a class, Kia needs to go through this list. So even empty classes, they decrease the performance by 7,000 leases. Because, you know, in typical reasonable deployment, you have like 5, maybe up to 10 classes. If you need more classes than that, then either you need to change your configuration or accept that your configuration is very complex and that there will be performance impact. So, and the third scenario is when there are classes with very simple expressions. So the expression is a constant string equals another constant string, the same constant string, which is basically always true. But Kia doesn't know this a priori. So for every incoming packet, it evaluates it. So this is like a good approximation of a simple class that's on its own would be like reasonable. Usually you want to, you know, like take a look at whether a specific option is there. Its MAC address starts with some specific octets or things like that. So, and here it's like a good approximation of what could happen if you go overboard with the number of classes. Then the number of leases drops to 12,000 leases per second. So if you take a look, by just defining the classes, you decreased the performance almost 3 times. So there's a price to pay for classification. So please be aware of that. Okay. So moving on, there's let's talk a little bit about hardware. So this is a bit fuzzy because there is no specific recommendation. So for the DHCP4 and DHCP6 servers, I mean the core part of the logic, the allocation engine, the limitation usually is the CPU. So you want to have a server with fast clock speed and number of threads makes a difference. Although we haven't done experiments on platforms that have massive number of cores, so we don't really know how well it scales. Kia is multi-threaded and the number of threads is configurable. So in principle, the performance should increase with increasing number of threads, but we know that this is not linear. It will like level off at some level. So with least backend, this is if you are using PEM file, there's least writes to disk. And this is important. If you are using any database, the round trip time it's also important. So try to optimize for disk access speed and network latency. For least backend, the major difference between least backend and the other 2 backends, host and configuration, is that least writes are like very roughly 50% of the access is writing, and that there's some reading. But with host reservation and configs, great majority is just reading from the database. So these are the parameters that you might tweak in your database. So also with configuration backend, the parameter you might want to tweak is the pooling time. So the idea is that you have one central database with your configuration and a number of Kia servers that are pulling the configuration from the database. So if you want to deploy the configuration like very quickly, you can decrease this. But overall, the larger the value, and the less time Kia will spend on pulling the configuration or looking for the configuration changes. So you might want to play with this a little bit. Okay. So a lot of deployments are using database. So what's the fastest way is to don't use database at all, use memfile. This is the fastest. If you can, do this and you will be happy. If you can't and you want to use the database, the next best thing is to use a database that is local, running on the same system as your Kia. If you can't do that, please make sure that your database is close in terms of network latency to your server. If you can't, well, you will have to pay the price. So this is something that that is hard to overestimate. I mean, like if the latency to your database is poor, your performance will be poor. So there will be a lot of threads waiting for the response. So also there's a couple aspects here that that we are starting to tackle. There's some deployments are interested in clustering solutions. From our perspective as non-database admins, these are hairy beasts. So we have limited experience in that. We did some experiments for MySQL and for Postgres. Some of them were a bit successful, others were failures. So we have a KB article about how Galera and Percona clusters can be set. This seemed to work well. We tested them pretty extensively and they seem to be working, not collapsing, assigning leases as expected, not assigning any duplicates, so working properly. This might be a solution. So because, you know, this is like horizontal scaling, I would say. So if you reach the limit of performance of a single server or a pair of HA servers, going with the database, this might be a potential option. So also, if you want to go that route, Kia can be pointed to different backends for different topics. So if you really want to, you might store leases in one database, reservations in another, and config backend in yet a different one. So typically people use the same database shared in all three, but you don't have to. If you want to like super optimize one for reading, one for writing, yeah, that's possible. Okay, so here's a bunch of general recommendations how you can reduce internal iterations in Kia. So if you have large subnets which have low utilization, this is better than small subnets with high utilization. Also, if you have fewer subnets and fewer pools, Kia internally has fewer configuration structures to iterate through, so it will be more performant. Also, shared networks. If you don't know what they are, don't use them. If you know what they are and you don't have a very good reason to use them, don't use them. The shared networks is something that complicates the internal logic a lot. So Kia has to go through, the internal logic has to go through much more complicated paths. So if you can avoid shared networks, that's definitely something you should do. Also, if you are doing reservations, just use MAC address or use one property and one identifier, not others. And there's also a parameter that in DHCP4 allows to look by client ID first, and then if the list is not found, look again using MAC address. So you can disable this and look by MAC address only. In great majority of cases, this works. Although in some cases it doesn't, especially when you're doing pixie boot, I think with some Anyway, I don't remember the exact details, but there are some cases when you really need the lookup by client ID. So if you need this, oh well. Okay, so moving on, there's a lot of different aspects in HA and multi-threading. So I think this is probably a topic that is wide enough to have its own webinar. So if there's a lot of questions, and I admit I'm not an expert in the HA area, so if there's a lot of questions here, we might consider doing a dedicated webinar on this. So anyway, one of the most important points here is that when you enable multi-threading, there is also extra knob to enable multi-threading in HA processing, because the normal multi-threading that we enable, it's just for packet processing. So there's a couple of slides that I have specifically on this topic, so I will cover this in detail in a moment. Second, hot standby is more lightweight than load balancing, so it's and then it's again, this is not an absolute, but overall the hot standby is a little bit more performant, because there's less cross updates between the server. So also there's a packet limit that you can configure. The idea behind packets is that there's a packet processing engine. So the packet comes in from the client, the server looks at it, assigns an address, but before sending back the response to the client, it needs to update its partner. So it sends the update, and we know that this will be a lengthy operation. So instead of waiting, it puts this packet on a parking lot and then starts processing next packet. And then one or two things will happen. Either a timeout will occur when there is no response, or there is a response from the partner acknowledging that, hey, okay, I updated the list. And then the packet is unpacked and sent back. So this overall works very well, except in cases when your partner is not available. So, and this is especially important because that's the whole point of high availability. You want to make sure that the solution survives the cases when there's no response. So if you configure this packet limit to too large value, then there will be a lot of packets waiting in the queue. So this will increase the memory footprint, and also it's not that good to have that many packets buffered. So, and overall, if you can, you should reduce the network latency between the HA partners. So I know that from the network resiliency perspective, it makes sense to to have the HA servers in different geolocations. But from the performance, you want to keep them as close one to another as possible. Okay, so another recommendation is that in HA, you have a pair of servers. You have primary and secondary. It's also possible to configure a number of backup servers. 0 is the typical value, but some people prefer to configure additional backup servers. The idea is that there is no automated mechanism to switch to those backup servers, but you can configure, like, let's say 2 backup servers, and then all the leases will also be stored on those servers. So then if both your primary and secondary fails, you have a backup with all the data that is up to date. You have to invent your own mechanism how to switch to the server, but still it's good to have a backup with up to date. So there is no specific limit how many backup servers you can configure. If you want to go overboard with this, configure 5. But each backup server adds least updates overhead. So, and it might be pretty substantial. So please consider that. Also, another thing to consider is that there's the heartbeat delay. So this is basically a time after which the partner attempts to communicate its partner and see if the connection is still alive. If you configure this to too low value, then it has negative implications on the performance. Also, if you set up the HA in a way that both servers share the same database, then you don't need to send list updates between them and list synchronization. So this saves a lot of time. So if you disable both of them, this increases performance. Although I must point out that there's a danger if your database solution here is not redundant, then you get an illusion of high availability because you have two servers pointing to a single database. If the database fails, both servers will be useless. Okay, so moving on, the next thing that I wanted to talk about is multi-threading in the HA context. So this is a bit historical. In Kia 1.8, we introduced multi-threading in the packet processing. So when there was traffic coming from clients to the server was using multiple threads to process those packets, and this was very performant. However, if you configure HA, you had to set up control agents, and then the server one connected to control agent of the second server via a single HTTP connection. That control agent used Unix socket to connect to server 2 to send back the updates and get back the leases. And both the HTTP and the Unix connections, they were sequential. There was only one of them. So this was the bottleneck that was causing the. It basically nullified all the performance gains that you had from the packet processing. The packet processing was mostly idle, just waiting for the for the responses. So we had to address this problem, and this is what we did in Kia 2.0. So right now, the DHCP servers they can open multiple HTTP connections between them, and they are not connecting to control agent. So you still probably want to run control agent to receive commands or get statistics, but not, strictly speaking, it's not necessary for the HA. So if you take a look at the example configs here, it's worth pointing out that here it's possible to misconfigure the server, that you have multi-threading enabled, the HA processing is also enabled, and then you misconfigure the ports and you point the server to still connect to control agent. If you do this, you will still go through the slow path and you will get poor performance. Although this is technically not a configuration error, so Kia cannot detect and say, hey, this is broken, because when you configure something in configuration of the DHCP server 1, it has no knowledge what exactly is configured under the port on the remote server. So this is something that it's very important, and I admit that a couple users tripped over this already. So they complained, hey, we enabled multi-threading everywhere and the performance was still poor. So they needed to change the port. Okay. So moving on, changing topic slightly, please remember that almost any capability that you enable in Kia, it's adding latency. So, and thus decreases performance. In particular, we have reduce hook. That is, I think this is the last piece that is still not multi-threading capable. So if you're planning your network and you want to use reduce, it will not work with multi-threading. So please be aware of that. We will look at this in the next cycle in 2.3. We'll look at the possible options, what we can do to speed this up. But it seems that the way the radius is implemented and the library that we are using, it's going to be difficult to make it multi-threaded. So we'll be looking at this, and I cannot make any promises at this time. So anyway, the current situation is that radius is not multi-threading capable, and there is no easy way to change that. Kia has a run script hook that for every list that is being assigned, you can call a script. This is super convenient. Lots of people love it. It's very flexible to update your inventory database, update your routing or whatever. But that means that every time there's a packet response being sent, Kia starts a process. This is a substantial overhead. So it's implemented in a way that it's asynchronous. So Kia doesn't wait for the process to finish. This is like fire and forget. But still, it's a substantial overhead. You know, creating the whole process. Typically, there's a bash, and then there's a script that does something. So this has serious performance implication. So basically, any hook with a database lookup has some negative performance implications. Also, with forensic logging, please be cautious. Forensic logging on its own, it's not a problem. It's just a way of write a different format of logging, but it's very flexible. So you can configure it to write to a database, and you can also use custom logging, which uses expressions. As I mentioned, if you use complicated expressions, this will be slowing down your performance. Okay, so another thing you can do is deal with the chatty clients. So chatty clients is basically a nickname that we came up with for buggy clients. That the protocol, the DHCP protocol specifies where the client is supposed to renew, but some clients are poorly implemented, there are bugs, and they are renewing yearly. So for example, in this example, we say, okay, you get a lease of 1 hour and you're supposed to start renewing after half an hour. But there are some clients that are broken and start to renewing after 5 minutes or even immediately. So we had one customer that complained that 9% of his devices generated 50% of the traffic because they were broken. And in many cases, you don't have control over this because, for example, you have a Wi-Fi network. So you have no control of what type of devices and with broken, outdated systems. So anyway, what we did in Kia is implemented a mechanism that was working well in ICDHCP, which is called a cache threshold. So the idea is that you can specify, hey, if there's a renewal and it's below the threshold, like in this example, 25% of the whole lease lifetime, ignore it. So we'll still send back a response, but we'll use the existing lease just renewed. So imagine we sent the first lease as in this example. So the client will get 2600 seconds. And if he renews after 1 second, he will get another response from us, but this time it will be 3599 seconds. So the difference is that Kia didn't change anything, so doesn't need to do any DNS updates. Doesn't need to write anything to disk. Don't send HA update or any other update can be skipped. So this is a mitigation. It's not a 100% solution, but it improves the situation tremendously. The best solution would be to fix the clients, but in many cases, this is not viable. So, okay, another thing that is important to keep in mind is that Kia has iterative allocator implemented, which means that it is going through the available dynamic pool through the addresses one by one. So at the very beginning, when the pool is empty, this is super easy and it's very fast. But the closer you get to full utilization, it's getting harder and harder to find the remaining free leases. So this is the performance report from the report that I already mentioned. So the idea was that we were running per DHCP, getting all the addresses. So, and in our case, it came up that around like 96%, the performance starts dropping. So if you can, please plan your network that your pool utilization will never reach those levels. Although I know that it's easier said than done, because sometimes you are simply running out of addresses. So maybe you should migrate to IPv6. Okay, so, and this is another reference to this reports page. There's, as I mentioned, there's a lot of interesting things here. For example, this is a part of the report that we did for 182. So here we simulated traffic for MySQL with multiple reservations. So, and as you can see, the yellow line at the top chart, it shows the number of reply received. So this is basically the packet that allocates the address. So the initial couple seconds, like maybe 30 seconds, it was working fine. But then a spike started to appear. So, and over time, the spike was either getting larger and wider, and over time it was degrading. So this is the kind of performance investigation that we are doing. So that's important from the perspective that performance is a complicated aspect. So if you look at this complex behavior and the process that's going on in there, you can overly simplify the whole thing and say, okay, I got X number of leases per second, and that's it. But this would hide a lot of details and complexities happening in your network. So, so if you are serious about optimizing performance, I encourage you again to visit this page and take a look at the report and look at the charts that we have there. They are interactive, so you can zoom in, scroll. There's tooltips for everything, so there's a lot of data. You can also download the config files, so you can repeat the experiments on your own if you want. So, and finally, it's like important to say honestly, there are upper limits of every performance. So you cannot really increase the performance indefinitely. And right now, with the numbers that we are getting, so I did pretty basic calculations. For the most performant scenario, we have 36,000 leases per second, which means 4 packets. So let's assume each packet is 300 bytes. This is very deployment dependent, how many options you send, but this is like a rough guess. So this gives you 540 megabits per second. Sorry, there's a mistake on the slide. There should be 43.02 megabytes. But still, this is like half a gigabit of traffic, of DHCP traffic. So that's a lot. With that amount of traffic, you know, the traffic control in your OS starts to play a significant role. So, you know, things like socket buffers, QoE disciplines, tweaking parameters in your network interface cards. These are all things that that might have an aspect. So we haven't explored this yet, because we feel that, okay, so if someone is able to get 36,000 leases per second, this is like good enough. So, but it's up to you how deep you want to go to increase the performance a little bit more. So anyway, and my last point is all the things that I said. You can take them for granted. You can believe me. You can not believe me. It's up to you. But the best recommendation is that you should verify it yourself, because I only talked about our own specific deployments that are, I want to stress out, they are artificial. They are not production networks. So in your own network, on your own hardware, the best thing you can do is to run your own experiments. So we provide a tool, PerfDHCP, which has a lot of options that can be used to simulate clients. So here's a bunch of options. The first one says, okay, simulate 1,000 clients and generate traffic of 500 packets per second. And then it will start hammering your server. So depending on how you play with the numbers, you can get, clients that are renewing very quickly, or doing stupid things, or going pretty relaxed on the server. So it's however you want. And the tool is very flexible. You can configure it to do the tests that should last for a specific number of seconds, or configure it to configure certain number of clients, or do many other things. So the more popular options are, you can specify a file with a list of MAC addresses. So this might be important if you have reservations, and then PerfDHCP will use that to simulate the clients. You can add custom options with -O, so you can simulate that way basically anything you want: cable modems, VoIP devices, special strange other devices that you might have in your network, you name it. It's also possible to simulate traffic from multiple relays, so it's not exactly as coming from multiple relays, but still the GI address field in the header that Kia pays more attention to will be different. So yeah, it's much better than nothing. And of course, you can play with the renewal and release rates. And finally, there's a cool scenario that I personally like a lot, which is called avalanche mode. The idea is that in normal network, when you have clients that are sending requests and the server is not responding quickly enough, the clients get impatient and start retransmitting. So, and this causes an avalanche. So if the server is clogged and the clients start sending more and more retransmissions. So this avalanche mode can be simulated in PerfDHCP, and you can also specify how impatient the clients can be. So what is the retransmission time? So that's pretty useful in my opinion. Okay, and finally, this is like a bit of an advertisement. We have Stork that has ability to get statistics from Kia, and you can export those to Grafana. And there's plenty of metrics, including aspects of DORA, number of packets per second for different packet types, overall number of assigned addresses, and so on. And if you are familiar with Grafana, it's super easy to tweak the statistics and do some arithmetics on them and gather some additional data from that. So that's pretty useful, and this is beyond just doing experiments. Many deployments use this for production networks. So that's also something that's very nice to have. Okay, so to wrap this up, this is the summary of the most important things that I hope that you will take away from this webinar. So it's best to not run full utilization close to 100%. You should disable the debug level in production. If the client classification is too complicated, this is a bad thing. Also, okay, I forgot to mention about the REST API. Some people like to get the statistics very frequently. If you do that, some statistics are expensive to gather by Kia. So if you want to get like full utilization every single second for all the statistics for all the subnets, and you have thousands of subnets, yes, this will slow down your server for sure. Also, don't load hooks that you don't really need. Please upgrade if you can, and when you enable HA with multi-threading, make sure that you enable this for both the packet processing and the HA updates processing. Okay, and finally, there's a bunch of useful materials that that you want to take a look at, and that's basically concludes my presentation. So, and I'm a little bit over time, so apologies for that. So, are there any questions?
I think that was pretty comprehensive, and so far we don't have any questions. We had one question from Kathy, which Marcin addressed. But I don't know that people can see the answer. So she asked, when creating a number of classes, if a packet matches a class, does Kia stop checking the remaining classes that have not yet been checked? In other words, is it sensible to put the classes that are most likely to be matched first in the configuration? And the response was that Kia will evaluate all the classes for a packet. It is sensitive to the order of classes in the sense that the classes can depend on each other. So classes that other classes depend on have to be specified higher in the configuration. But it sounds as if the answer to this question is that it's not really, you don't organize your classes in order for performance optimization purposes.
Mm-hmm. Yeah.
Would you agree with that answer? Is that?
Yes, and the reason for that is that classes can mean different things. Like you can have a client, you can have a class that represents Android phones, and then a class that represents customers that have gold level of support. So it's possible that packet can belong to multiple classes, and they're not exclusive. So.
Okay, well, we don't have any other questions, and so I think we can finish. And I will send out an email in a day or so with a link to the recording for everyone who's looking for that. So thank you very much for this very comprehensive webinar. Tomek, this was great.
Thank you, and have a nice day.